Hello and welcome back to Compiler Programming. Today I thought I would work on this issue, which is raw inline assembly, or not really assembly, but just the ability to say, okay, I'm gonna specify these bytes and please treat them as like just inject them into the output machine code. Don't try to do anything fancy to them, just these are the raw bytes, take them as is and pipe it to the output. Because assembly essentially is just mapping right between the mnemonic and operand to those bytes. And my goal long term is to have the assembly be just regular macros that will do that mapping for us. And as such, we won't really have assembly support in the compiler. But the first step is, of course, to be able to output those bytes. And I don't want to break the compiler completely while I do that. So the plan right now is to introduce like this form as sort of an extra that we will handle. Okay. Before we start with that though, oops, let's close it down. Before we start, let's check what we have right now as an instruction type because we will need to change it. And at first, I want to turn it into something else, or rather, make it like a tucked union because it already is, even though it pretends it isn't. Right? There is this maybe label, and if we have an instruction with label, then we don't really have an instruction. Like if we use a label, we can't have other things here. Like there is common stuff like these things over here, but it is not. But these things are not always used, right? So this is a part I would like to extract somehow, and I guess we will have type def enum, and I would call it instruction type very unimaginatively, and it can be instruction type assembly, it can be instruction type label, and it can be, well, the next one we will do when we get to it. Let's just not mix it up. And here then we would have instruction type, I guess, or just type. And a union. This might break a lot of call spots, so we'll need to see how to handle that. So there might be a bit of dumb refactoring on this video, but you know, that's fine. So here it will be a union of these two, which we will call type def struct instruction assembly, and we'll put these here. So that's gonna be assembly. Like so. And the other version is, we won't call it maybe label, we'll call it label because now it will depend on the type. Yeah, so I said this is going to generate a lot of errors, right? All kinds of stuff like from missing operands to other fun things. So we'll just have to go through it and do something about that. Okay. So in here, I think we don't expect labels to be a thing. So that means that we can just say that we assert that instruction type is instruction type assembly, right? Anything else should never come to here, and we will handle it in other places. This is just the encoder for this. Then we can also then maybe rename this stuff to encode instruction assembly. Okay. Let's get back up here and say that means that now operands live in assembly, right? Okay, that's correct. This goes into here, oops, into here, and here. Okay, that looks pretty good. And now this code is also pretty straightforward. We say if instruction type is instruction type label, then we take that label and we assert that it exists. I might even not need this variable, to be honest. Like, it's not very complicated. Or maybe it's fine to have it. Let's just leave it as it is. Okay, here we have this is just count of, I think. So count of instruction assembly operands. I don't know why it was spelled out like this. And here it is the same thing where we just need to put a bunch of extra words in the place. But this file is pretty much done, right? Cool. Let's continue to the next one. Okay, so push instruction is going to be the nightmare of a change because we now need to also add a tag and it's in the wrong place. How do I want to handle this stuff? I guess what I could do is do sort of two-step replacement. We'll make sure to have consistent spaces here. So we replace all of these. This does not change anything, of course. But now we can start doing maybe stuff like this, where we would say instruction type assembly. Or do I want to just like augment push instruction with this stuff? Yeah, that actually would be better option. So let's undo that thing. And what we will do is we will call this stuff like so. We'll replace push instructions with push assembly, right? And push instruction is defined. I don't think it's defined here. Maybe it's in the here push. No. Maybe then it is inside function.h. Instruction, yeah. So instruction is defined here. It's a macro. Now we say let's push assembly. And we need to change a few things. So first of all, let's create this thing where we so instruction mark as assembly. We say instruction type is actually it will be by default, right? Yeah, so this is 0, so that means by default it will be the right thing. And we won't need to do anything here. But then do we even need to change to push instruction? That's a question. Let's think about this. So our trouble right now is in the extra set of braces, right? And no, it's like this. It's a bit more than that. It's extra set of braces and an extra word. Well, I guess I don't see a good way how to do it automatically, unfortunately. I think my original idea would be the closest thing that we would have, but unfortunately we cannot auto close the brace, so you know, manual it is. Although let's do it like this. Instruction, and we are gonna replace it with the following. Okay. Like so. And since we still have things marked from the errors, we should be able to pretty easily add these curly braces. Right. I probably should add curly brace matching to my editor. Okay, this is something else. We'll take a look at this stuff in a bit. Right now, I'm only interested in push instruction and want to fix all of that. Okay, this one actually will be different. So here we need to say type is, yeah, maybe even spread it. Type is instruction type label, and then label is label start. Yeah, so that's better. Few more curly braces. Okay, it seems that we actually get pretty decent error reporting even if I do it incrementally, so that's good to know. That's another case of maybe label, so we have to search for that, but it will remain a syntax error actually anyway because of type don't match. It will be a type error. Okay, so that's a bunch of stuff. Syntax error. Yeah, we manually did these, but then also did them automatically, so that's not good. Maybe this here. missed one as well. One more here. Okay, well, that's not too bad. Yeah, somehow missed a bunch in here. Okay. Looking better and better every day. Now, how do we deal with that? Well, let's think for a moment. I'll just do it manually, it's fine. Because I want to reformat this as well. Instruction type label, and then label is this. Okay, looks good to me. Here it's also else label, and here it's label. Okay. If last instruction type is not instruction type assembly, then return. So this is equivalent to doing this, and now this will be assembly mnemonic and assembly here. Okay, we have to add assembly here as well. Type is instruction type label, and label is this. Okay. Here it's actually just missing curly. And we'll take this one from here and just change the label to be this one. Okay. Looks like this file is done. Let's continue to the next one. Here it's pretty much the same setup, right? We can do the replacement of these things. It should give us the base for fixing it. Again, labels will be handled separately. But there aren't too many of either of those, so that's fine. This one was wrong. Oops, no, I can't do that. So we take this thing and put it into here. Okay. This is the maybe label problem, which we can fix. And another maybe label problem. Cool. Ooh, who else is broken? Ooh, instruction equal. That's actually sort of broken already because it doesn't look at maybe label. So good that we saw that. Well, first of all, if a type is not so the types are different and it's definitely not the same. And then we do switch of a type. If it is assembly, then we do whatever we were doing before. Actually, like so. If it is a label, then we simply say return a label is b label. And here I will have to do this. Okay, that is definitely progress. Who else is unhappy? Okay, and what we are left with is just a bunch of tests which we can fix. So mnemonic is assembly mnemonic, or this. And the same goes for operands. Operands. Okay, that helped, I think. Now the trouble is in places where we compare different instruction types. Okay, well, we know how to fix that as well. Okay, here, 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 and here. A few more. And I think we are almost done. Okay. Cool. Well, now let's see if we broke anything, because that's a lot of changes and I might have screwed up a few, but apparently I didn't. Everything seems to be a-okay, so we are ready to roll. Let me check which episode we are on. It's 118, so let's make a commit. Episode 118. Change instruction into checked union type Oh, it's fine. We'll just leave it like this. Okay, that was the first step. We're just refactoring in preparation for the real thing. And now for the real thing, we would say if instruction type is bytes, then we would, I guess, for bytes we can just use slice. So we'll just say slice bytes, like so. Obviously, this thing complains, and this is why tag unions are pretty good even in C. Type bytes, a bytes, actually slice equal a bytes and b bytes. Okay, that is nice, but that is definitely not all. We need to also take care of them in here. And I would prefer to switch this to a switch, but I will not do it right now because it will require a bunch of code moving around. Turn into a switch statement on type. So for now, I'll just do this. Else if instruction type is instruction type bytes. Okay, so what do we do? Well, first thing is encoded byte size will be equal to the slice of the slice. So we'll say instruction slice length. That's pretty easy. And then I guess the only thing we need to do really is something like fixed buffer append slice and instruction slice, something like this. Oh, it's called slice, it's called bytes. Yeah, so u64 to u8. That might cause some issues later on, but let's see. So we would, at least right now, that means that we would require to issue sort of individual instructions for every inside of whatever we will add right now that will allow us to push bytes. We will have to limit the amount of bytes to one instruction. Because otherwise here it will be very weird. Like we expect this encoded size to be less than or equal to 15. And also I think in things like mapping from instructions to lines of code will have issues. So it's fine, and then we'll later figure out if you want to like really say, okay, here's just a blob of code and do whatever you want with it. For now, this would be sufficient. Okay, so that is the side of the encoding. Now we need to have the side of, not the other side. Okay, that will go into the source. And let's open up source spec dot c and figure out a test for this. How would that look like? So traditionally, when you're dealing with assembly, you have this setup in different languages. Let me open up Firefox and show you how it looks like. and why it does what it does. So let's just, I don't know, search for Rust inline assembly. Yeah, so here's how it looks like in Rust. You pass it as string, and then there is a bunch of colons and that do different things. So what does it all mean? Well, you have the actual bytes, actually not the bytes, but actual assembly that will be turned into bytes, which the step I would like to avoid. Then you have output operands is, I think, how you will get the result out. Yeah, so you will say that it will come into here. Then you have input operands, which is something that like you pipe in. And there is another column which is like clobbers, which means that it will affect this particular register. I don't know if you can specify memory there. Probably not. And then there is some other whatever options they use. The reason I bring this up is that we also need to figure out how to do those things, but I think I want to separate them from each other and provide like even lower level capabilities. So right now we'll just essentially do this, and we straight hard code all the values, and then input and output will be implicit. And output I think is perfectly fine for it to be implicit in general, because I like assembly is specific to architecture anyway, so you have to really know where you're gonna get it out and how to get from there. So I think that's fine. And inputs, this is where it might be a bit tricky right now. Like I would have to sort of know, for example, the calling convention that we are on and stuff like that, which is not particularly great. But you know, that's fine for now. So what I will do, I think, is I will add a test. Let's think about where we want to put it. So the test will be, I can put it as the first test because eventually all of these will use this one and should be able to include raw machine code bytes. Okay. And in here we somehow need to specify it. Probably the easiest thing would be to have it as a function right now. Let me think about this. Yeah. Ideally, long term, I want to get to being able to specify it without commas, but honestly, right now, I think it's going to be fine. And we can do something like this. We can say, let's be verbose, it's fine. Machine code bytes, or even inline machine code bytes. And it will be something. So this is an S60 function return in S64. So if we go back to here and we just use this inline assembly, we can say move rax 42, and it will give us the bytes to put. And this is exactly what we will do. we already have parsing of hexadecimal numbers, so these should work. And I will define now a macro that will do this kind of stuff and be happy. Now, we will have an issue that this thing will complain that we are not returning an S64, so it will be a type mismatch. I will not deal with that for now. I'll think about how to handle it first. So fix me return type here should be S64, but then it will expect a value to return which does not exist, as we are dealing with machine code bytes directly. Okay, that's just for me. And here it is still the correct type because we are sort of manually fulfilling the expectations. I can also start tagging maybe these tests somehow that they are Windows only, because eventually we'll need to filter them out, so can start right now. Okay. So after we are done, this test should pass. Obviously, if I run it right now, it will be like, what? I don't know what you're talking about. Yeah, it doesn't even gracefully end, it just crashes. So let's figure out why it crashes. So we end up with operands where one is not there. Who is asking? It is move value. Who is talking to here? Okay, so yeah, it wasn't able to look up the identifier. Let's figure this out. So this isn't token force value. Token force value. Yeah, so basically we just need to say if not value or if value, then move. Otherwise, don't bother because it doesn't make sense. I wonder if so. Does scope lookup force actually report the error already, or it does not? Scope reverse is force lazy entries. Doesn't look like it reports. So let's maybe end that. So we take the name and we say name undefined variable, and then name. Program, location. Ooh, yeah, at this point it doesn't really have a location, so maybe we do need to do it here. First location, name is that should be better. We should obviously that should still not pass, but we should get an error. Well, that's a bit more errors than I expected because it's wrong. Okay, still not happy. We are in exactly. Yeah. So it should be like that. Okay, that's what I wanted to see. Find variable. Actually, it looks like we have multiple things. So let's clean this up. Ah, oh no, I guess it's fine. I can fix it up later. Okay, back on track. We were now we need to support these kind of stuff. Well, we have other functions, I think, that we can take a look at. So what do we have here? We have match struct, rewrite struct. There is cast, I believe. Yeah. So that looks pretty good for what we are trying to do. I can say token, rewrite, how's it called? Inline machine code bytes. We'll look for that and the parentheses, and it will try to parse the arguments. Okay. That is perfect. We don't care, I guess, how many there are. Yeah. And we do care if there are more than 15 of those, but maybe not right now. To do error out if there are more than 15 bytes, at least on x64. And now what do we do? Well, we can create a fixed buffer. Fixed buffer star buffer is fixed buffer make. Allocator is temp allocator. And capacity is, well, we can say 64 byte count is this. Okay, now we just iterate over this. We get the value, args dynamic array get. Whoops, I definitely don't want to start writing in Cyrillic. Args I. Good. Then if that value, then value is value from S8. So this is basically error handling or error recovery, sort of. And next, we need to say if value descriptor type is not descriptor type integer, then we need to report. For now, let's say to do report error. Actually, here we can just do this continue. So just skip that. And continue. We also expect this to be an immediate, right? Because we cannot insert new instructions on runtime, or at least not in this manner. Of course, we can do JIT like we are doing here, but that would look very different and we'll use very different mechanisms. So what we also need to do is we need to say that operand is immediate of value operand. So if it's not immediate, we also continue. And if it is immediate, actually, if now operand type is not operand type immediate 8, then we also need to report an error because we can only have bytes here. And finally, we are ready to roll. In particular, we say buffer fixed buffer append S8 of buffer and value operand immediate 8. Okay, that's all we're going to do. And we need to have a new value. No, we don't. We will replace it with nothingness, but we need to push this instruction to the right place. So let's get some push instruction code and do the following. So this is push instruction, builder, code block instruction, name location. That's not gonna be called cast. That's gonna be ID. And this is not the value token. This is args token. Okay. I think I did the wrong thing. Yeah. Args token ID token. this goes in here. Okay, we of course don't have a label, but this is not what we are after. Bytes, let's maybe spread it out across different lines. Bytes is gonna be fixed buffer as slice of buffer. Okay, let me take a quick look if it makes sense. We have function call essentially. We get all the arguments, we verify that they're just bytes, and we push that instruction to the end. That's good. Now we need to just add these into statement. Yeah. And here we can say token match end, right? We expect this to be a separate statement from everything else. Okay, so let's see. Well, something happened, but let's see what exactly is the thing. So we are trying to size up yeah, that of course will not work because I forgot to do return here. That's sort of why I want to turn it into a more standard format for handling different types. Okay, that is an improvement because it looks like we got the program to encode, but something was not right. So first of all, let's do the following. For U64I is 0, I is less than instruction. Actually, we can look at it in the debugger. I don't need to print it out. Where is this? It's here. Okay, buffer. It has some bytes in it. Now we need to look at instruction. Instruction is bytes, and bytes is 5. We can do and watch and instruction bytes length bytes I'm not sure how I can force it to show the right thing. I guess like this. Well, that looks perfectly fine to me. So the question is, what then happened in the encoding afterwards that made it go haywire and have a violation? Should be able to tokenize. Where's our test? Okay. disassembly, and let's see. Wait, it's missing a few things. So we got 48. We got 2A. It means that these actually failed. But failed in some very interesting way where because I guess we don't report errors. Well, that would be certainly a good point to do those. Oh yeah. This is what I should be doing because the logic here is incorrect. S64 value is operand immediate S64 value operand. So what was going on is we would have like C7 is negative if treated as a signed integer, and our logic is right now very shaky with signs versus unsigned. Until I fix that, I will have to do other things, but what we're going to do here instead is going to be correct regardless of how I represent, right? I always get 64, and if I say if value, actually if byte is less than 0 or byte is more than 255, then this error happens. Otherwise, I'm gonna append U64 or actually S64 to U8. And here we can actually say if byte, if U64 fits into U8, okay, let's try this out. Okay, so here we go. That is our machine code inline support in the compiler. There is a bunch of stuff that needs to be done. So right now we only can insert bytes, but I would prefer to also be able to put like labels in here. There is still stuff to figure out around the return. There is stuff to figure out around how do I acquire registers, how do I release registers. Like all of that is definitely needs to be happening. But what I want to do today is working splendidly. That means we are done. I will commit and push these changes, and that's gonna be it. So git add this, git commit episode 118 support inline machine code bytes fixes. Let me open Firefox here. It fixes number 8. Okay, so thank you very much for watching, and hopefully see you next time.